4.8 polynomial equations. So now we want to take all of this factoring stuff that we talked about and we want to apply it to equations so that we can start to solve. Okay, but we do need one definition in order to officially look at that. So our first and only definition is called the principle of zero products. Okay, and it states if A times B equals 0, so A times B equals 0, then either A equals 0 or B equals 0 or both. One of those two things have to happen. Okay, so the only way for this thing to equal 0 is for one of these two things to be 0 or both of them to be 0 for our options. And so we're going to use that to our advantage here. Okay. All right, so let's look at our examples. So we want to solve. So our first one is x squared plus 20x plus 100 equals 0. Now, when we're solving these, the first thing that we need to make sure that we have is it equals 0, because our piece over here says equals 0, and we're going to utilize that to our advantage. Okay, so since this equals 0, what I want to do is factor this piece. By factoring, I'm creating multiplication, something times something else. So we want to do that. Okay, so it's a trinomial. There are no greatest common factors there. So we're going to break that apart. I see my signs are the same. They're both plus. So for x squared, we're going to get x and x. And so for 100, we've got a lot of different things there, but we're going to see in this case that we get 10 and 10. And we can do a check if we need to, but at this point, you should be able to get straight here without checking. But 10x and 10x is 20x for those. Now that we factored, we have it equal 0, what we can do is we can take each one of these. So x plus 10, so there's my first one, equals 0. We can take our second one, x plus 10 equals 0. Now, because they're exactly the same, we don't technically have to work both of them. But that doesn't happen very often. Here's an example of where it does happen, but usually they're going to be different. Now we minus that 10 over, so x equals negative 10. I'm going to go ahead and work it over here as well. But since they're the same number, my solution set is negative 10. Okay, x equals negative 10 for that problem. So that's the only solution that happens to work there for this. Now, we may find that there are times that we can't do it. There may be no solution. We're probably not going to have that in any of our problems. But sometimes we have one, sometimes we're going to have two. So it's all based on the equation given. All right, number 2, x squared plus 25x plus 100 equals 0. All right, so it equals 0. There's not a greatest common factor. So we can go ahead and start factoring the trinomial. So here we have our parentheses. Make sure that you're writing equals 0 here. We got to keep going with our equation. Remember, if we start with an equals, we end with an equals. So we have to keep doing that. Okay. All right, so again, signs are the same. They're both plus. So x squared, we get x and x. Now for 100, we don't want to use 10 and 10 again because that got us 20, not 25. So we need to find something else that's going to work there. Okay. And so if we do 20 and 5, we'll get 25 with that. Okay. All right, so that means x plus 20 equals 0 and x plus 5 equals 0. So we move this over, so x equals negative 20 and then x equals negative 5. So we get negative 20 and negative 5 as our solution set. Now you can always check your answers. You can take those numbers, plug it back into the original one at a time, and you should get a true statement, right? Remember, a solution makes that true, so we can do that. All right, x squared plus 3x equals 28. All right, so here it does not equal 0. So since it does not equal 0, we need to make it equal 0 by moving that 28 over. Now, I always want to move it so that my x squared comes out to be positive. My x squared is already positive, so I want to move the 28 over and put it in order. So x squared plus 3x minus 28, because we're subtracting to the other side of the equals. Now I can factor that. Okay. Well, this time my signs are different. X squared, I still get x and x. And then for 28, we get 7 and 4, gives me 28. And I need that 7 to be on the plus. Okay. All right, so x plus 7 equals 0. X minus 4 equals 0. So I'm going to move that over. So x equals -7 and x equals 4. And I do need to see all of this, okay? I need to see you separating it. I need to see those pieces where you set it equal to 0, not making the big assumptions when you're showing your work. So -7 and +4 are my solutions. Okay. Number 4. Grab my sheet here. 2x squared plus 3 equals -5x. So again, hopefully you see, does not equal 0, so we need to make it equal 0. So let's do that. We're going to add that 5x over. But we do have to put it in the correct order. So 5x and then the 3, so that we do it correctly. Okay. Now we can factor. All right, they're both the same sign. They're both plus. 2x squared, we're going to get 2x and x. And then for the 3, we're going to get 3 and 1. We got to play with it a little bit, but it should come out. So I'll check. We get 2x and 3x give me the 5x. So we do want to make sure that we check that one because there's a couple of different combinations. All right, so 2x plus 3 equals 0. X plus 1 equals 0. So we move that over. 2x equals -3. So x equals -3 over 2, or x equals -1. And so those are our solutions for that one. Okay. All right, let's do one more. So we see something a little bit different. X squared equals 25. Now, even though I just have the 2 pieces, we still want it to equal 0 at this point. Okay, so I'm going to move that over. So it says x squared minus 25 equals 0. Well, that's the difference of squares. So we can put our 2 parentheses, plus, minus. We get x and x, 5 and 5. And so x plus 5 equals 0, x minus 5 equals 0. So x equals -5 and x equals +5 is my 2 answers. Okay? So we still can do those. Now we cannot do cubes because the trinomial is not factorable. So we don't know how to do that yet. We can do that maybe later on. We're going to learn some other things in a different unit. But for now, we can do trinomials and we can do binomials for those that have squares. Okay. Let's look here. I do have another one before I do this one and one more. All right, so this one we kind of try to trick you. A lot of you see the minus, you see the x squared, you even see the 4, but we missed that x after the 4. Technically here, we need to factor off the x. There's an x in common. So now there's not a square anymore. This is not difference of squares. We have an x and an x minus 4. So it's still multiplication. So x equals 0 and x minus 4 equals 0, or x equals 4. So we still get the two answers of 0 and 4 there. I see this one missed all the time because we want to assume it's a square minus a square, because that's what we just did. But really, you need to factor out the GCF here, and then you will be able to get your answer pretty quickly. All right, this one, x squared minus 4x minus 45 equals 0. Now, even though we can factor this one, on this particular problem, I'm going to give you the graph. Now, it's going to be a sketch of the graph, so bear with me. And we're going to be able to see these 2 points here. They're going to be -5, 0, and 9, 0. You're going to be able to identify those pieces, okay? And so those pieces are a good thing to know. If we can look at the graph and we can see where does the graph cross my x-axis, those x values are the solutions. And so that means here that my solutions are -5 and 9, just by looking at the graph. And this is why we don't allow a graphing calculator. I need to know that you can factor, not look at graphs every single time for those, okay? But if they give you the graph and you can identify where it crosses that x-axis, then you have the solutions just as well, okay? So this is why we see it is important to be able to factor, be able to work through it so that now we can start solving our equations and identifying the things that we need. So we want to be able to get through these. You also need to be able to still factor, so we're going to use those in the next chapter as well, okay?